Okay, class. We have section 2.2 factors and prime factorization. Section A, finding factors of numbers. Recall that when numbers are multiplied to form a product, each number is called a factor. In this section, only the natural numbers 1, 2, 3, 4, 5, and so on will be considered in finding factors of numbers. That means that 0 is not included. No decimals, no fractions, or negatives. Example, we will look at the factors of 45. The two number factorizations of 45 are 1 and 45, 3 and 15, and 5 and 9. These are the only natural numbers that when multiplied will give you 45. So we scroll down here. Thus we say that the factors of 45 are 1, 3, 5, 9, 15, and 45. So we have 6 factors of 45. Now I want you to notice something here. When you line them up in order, what you could do is this here. 1 times 45 is 45, correct? So it's the first times the last. Now we come here. We go the second to the second last. 3 times 15 is also 45. And then we have the middle two numbers. 5 times 45 is 45. Now this lets you know the factors you have. Now here's a helpful hint. You can use division to find all the factors of the number. And you must have a remainder of 0. So 1 goes into 45 45 times. That's a remainder of 0. 3 goes into 45 15 times. 3 goes into 4 once. And then we have 15 left over. 3 goes into 15 5 times. And we will have a remainder of 0. We know 5 times 9 is 45. So 5 goes into 45 9 times. 9 goes into 45 5 times. Now 15 goes into 45 3 times, because 15 times 3 is 45. And 45 goes into itself 1 time. Now we could use this for the next set of examples. We have example set A. Find all the factors of each number. So we take the number 15. We ask ourselves, first of all, we always do 1. 1 times 15 is 15. Now we try and think of some other factors. We know 2 times any other natural number is not 15. But we know 3 times 5 is 15. We know 4 doesn't work, 6 doesn't work, 7, 8, 9, 10, 11, 12, 13, or 14. So these are our factors, 1 and 15, 3 and 5. So we write them in order. It'll be 1 times 3 times 5 times 15. So our factors of 15 goes like this. It'll be 1, 3, 5, 15. These are our factors of 15. Now we go here to 7. Now 7, the factors of 7. First we start off with 1 times 7. Can you think of any two other natural numbers multiplied together that would give you 7? Me neither. So our final answer for 7 is 1, 7. These are the factors of 7. Now we come to 24. So we take 1 times 24, 2 times 12. We have 3 times 8. And we also have 4 times 6. And there's nothing else that we could think of that would give us 24. So the factors of 24 are these here. We have 24 is equal to 1, 2, 3, 4, 6, 8, 12, and finally 24. These are the factors of 24. Now, I need to go back up and make a correction to number 1. This 1 times 3 times 5 times 15, this is not how you write the factors out. Because when you multiply this, this would give you greater than 15. We could just leave the factors here to the side. We have 1 times 15, 3 times 5, and then we could write our final answer here. Just going to circle our final answers. Okay, now we come to number 3. The factors of 25 are 1 and 25 and 5 and 5. There are no other natural factors of 25. So our final answer here is 25 is equal to 1, comma, 5, comma, 25. Now if you notice, we didn't write 5 twice. Whenever you come to a situation where your factors are the same, you only write them once. So our final answer here is 25 is equal to, and you have to excuse me here, sometimes this pen jumps a little bit, but it's circled 25 is equal to 1, comma 5, comma 25. And that is your final answer. Now, we come to section B, identifying prime and composite numbers. We are going to concentrate on a special way to factor called prime factorization. In order to write prime factorization, we must review prime and composite numbers. Okay, prime numbers. A prime number is a natural number that has exactly 2 different factors, one in itself. Here are a few examples, but it's an infinite amount of prime numbers. We have 2, 3, 5, 7, 11, 13, and etc. Now I want you to note here, 2 is the lowest and only even prime number. So all, aside from 2, all of the rest of your prime numbers are going to be odd. Okay, think about that. 2 is the only even prime number and is also the lowest prime number. All the other prime numbers would be odd. Now our composite numbers. A composite number is any natural number other than 1 that is not prime. All even numbers greater than 2 are composite. And then we have 9, we have 15, 21, 27, etc. Again, look at this. All even numbers greater than 2. So you have 4, 6, 8, 10, and so on. All of those even numbers that are greater than 2 are composite. Then we have some of these other numbers, 9, 15, 21, 27, etc. So composite numbers are even and odd numbers. It just doesn't stop at 2. I mean, actually, 4 would be the lowest even composite number. Now, we have a helpful hint here. The natural number 1 is neither prime nor composite. So, we go down here to example set B. It says determine whether each number is prime or composite. Explain your answers. Okay, for problem number 23. Now, is this prime or composite? Okay, we could look at the factors. We have 1 times 23. Now, there aren't any other factors that are natural that multiply that would give us 23. So here 23 is prime. Now we look here at 35. Our factors of 35 are 1 and 35, and we also have 5 and 7. This has more than 2 factors, so our answer here is composite. Now for 26. 26 is even. Now remember, we said the only even number that is composite is the only even number that is prime is 2. All the other even numbers that are greater than 2 is composite. So 26 is even and is greater than 2. Now we come to number 4, which is 9. The factors of 9 is 1 and 9 and 3 and 3. Now, we have more than 2 factors of 9, so automatically we know our answer is composite. Now we need to scroll down. I hit the side button just a little too fast here and it jumped, so I need to scroll back up. So we come here to number 5. We have the number 14. Now that is an even number and it's greater than 2. So automatically we should know that that is composite. Now we look here at number 6. It's an even number greater than 2. So that is also composite. Now we scroll down here to section C. Finding prime factorizations. Now we are ready to find prime factorizations of numbers. Prime factorization. The prime factorization of a number is the factorization in which all the factors are prime numbers. For example, the prime factorization of 12 is 2, 2, and 3. 2 times 2 is 4, times 3 is 12, which we are shown here. 12 is equal to 2 times 2 times 3. This product is 12 and each number is a prime number. So that is prime factorization. Note, every whole number greater than 1 has exactly one prime factorization. So any whole number you could think of that's greater than 1 has a prime factorization. There is another way to find the prime factorization. This way is called divisibility. Divisibility is a number that divides evenly, no remainder, into another number. In the chart below are a few of the divisibility tests using prime numbers. Now a whole number is divisible by 2 if the last digit is 0, 2, 4, 6, 8, 6, or 8. So it's 0, 2, 4, 6, or 8, which we commonly call even numbers. If it's even, 2 can divide evenly into it. Okay, we look at this number here. We have 333,378. Since the last digit is 8, then it is divisible by 2. Okay, now we come to the number 3. If the sum of the digits is divisible by 3, so this is what happened. It is divisible by 3 if the sum of the digits is divisible by 3. Example, we have the number 78. Even though it's even, it is divisible by 3 because 7 plus 8 is 15. So we know 3 goes evenly into 15, so that means that 78 is divisible by 3. Now we come down to number 5. A whole number is divisible by 5 if the last digit is 0 or 5. So any number that you come in contact with, if the last digit is 0 or the last digit is 5, it is divisible by 5. So we have 333,375. Since the last digit is 5, then it is divisible by 5. Okay, if you look here, earlier the divisibility test used prime numbers. But there are some other commonly used divisibility tests that use composite numbers as well. For example, we have 4. If the last 2 digits are divisible by 4, then the whole number is divisible by 4. For example, we have 333,312. We look here at the last 2 digits. This is 12. 4 goes evenly into 12, so this whole number is divisible by 4. Now we come to 6. Now 6 borrows from the rule of 3. This is what happens. If a number is divisible by 3 and even, then it's divisible by 6. For example, 78. We knew 7 plus 8 is 15. That's divisible by 3. And since it's even, it's divisible by 6.